Hello again, and welcome to this UNI.MINDS session dedicated to soil and water health. As all sessions, also this session is being recorded. My name is Tina, and I'm honored to be your host today, along with my co-host Vesna Milicic. UNI.MINDS Festival is organized by Knowledge and Technology Transfer Offices of University of Maribor and University of Ljubljana, in association with our industry partners and supporters from the innovation community. The main partner of the event is Novartis in Slovenia. This festival would not have been possible without the support of Republic of Slovenia and the European Union under the European Regional Development Fund. In this parallel session, we will give a snapshot of competences, innovative projects, and good collaborative practices in the field of soil and water health. Each speaker will have a 3-minute long presentation, followed by 3 minutes for questions and comments. After all presentations, we will encourage you to have an open dialogue. We are especially interested in how to join forces in the future development trends. But before giving the floor to Vesna, I would just like to present some basic rules. I will be a timekeeper, so whenever you see me after this introduction, it means the end is near. If not already, please rename yourself in a way we know what to call you. Throughout the event, we encourage attendees to keep cameras on so you can see each other. We encourage you also to post and ask questions and make comments. During the presentation, please use Zoom chat box, and after the presentation, you can raise your hand and you will be allowed to speak directly. Let me introduce you to Vesna Milicic, who is a senior consultant and Chamber of Agricultural and Food Enterprises within the Chamber of Commerce and Industry of Slovenia. Before this position, she worked as a senior policy advisor at the Ministry of Agriculture, Forestry and Food, where she mainly covered the topics related to innovation, digitalization and knowledge transfer in agriculture. While working at the biotechnical faculty as a teaching assistant, she gained excellent knowledge in various agricultural research projects related to rural development, marketing, agriculture, economics, and aquaponics. And with this in mind, I'm giving the floor to Vesna, who will be moderating this session. So Vesna, the floor is yours.
Thank you very much, Tina. Good morning to everybody. It's really nice to see you all gathered together. I'm really honored to be in such a good company, and I will lead you throughout this morning session until 11:15. So I'll be your moderator together with Tina. So first of all, we are here at the breakout room dealing with sustainable soil and water health. So just to, let's say, briefly introduce to this breakout room, as you know, soil and water are two of very important natural resources. They are so important that FAO, or this General Assembly of the United Nations, decided that in 2013 we were celebrating the International Year of Waters. So basically dealing with the cooperation on the area of waters. And in 2015 we celebrated the International Year of Soil. So as you can imagine, those two natural resources are being really important. So we also, basically the United Nations declared 2 international days. So we are celebrating 22nd of March as an International Day of Waters and 5th of December as an International Day of Soil. So the importance of soil and water as a natural resources is gaining, basically is rising, not only in terms of ecosystem services they provide, but also for the agricultural production. As we know, the population is rising in the world, the demand for food is increasing, so that's why we have to keep our natural resources safe and sound. And we will be now hearing the presentations relating to these issues. So about all this innovation and innovations, basically dealing with this topic. So with this regard, I'm giving the floor to our first presenter, Professor Dr. Kristina Sepčič from the University of Ljubljana. She will be talking about the development of new bioinsecticidal proteins that have been isolated from the edible oyster mushroom. These proteins are selectively toxic to the larvae of important plant pests such as western corned rootworm and Colorado potato beetle. The toxic effect is due to the binding of these proteins to a unique molecular target, insect-specific membrane lipid. So the invention is protected also with an international patent application. The proteins are currently in the process of being tested in a selected biotechnology company with, of course, strong expertise in the field of plant protection. So please, Ms. Sepčič, the microphone is yours.
Thank you very much. Good morning. It is my pleasure to present you today our invention that is a fruit of a collaboration with researchers from Agricultural Institute of Slovenia and with the Knowledge Transfer Office of the University of Ljubljana. So for the introduction, I'm showing you here a maize field devastated by western corn rootworm. This is an insect causing a lot of costs and over $1 billion American dollars per year. And in these days, mainly these insects are controlled by synthetic pesticides that are effective, but they can accumulate in soil and be toxic for dangerous for the environment and also for non-target species. So the market projection of pesticides showed here shows that this production of synthetic pesticides will decrease all over the earth, while biopesticides will increase. These are environmentally friendly new generation of pesticides. But there is a problem. The insect pests have this tedious ability to develop resistance to both kinds of insecticides, and this is one of the major problems of agriculture today. So this is our invention. We found that an edible oyster mushroom produces two kinds of proteins, agrolysins and MACPF proteins, and these proteins have the ability to combine into transmembrane bicomponent pores. In other words, they bind to the insect cell membrane and they punch this membrane, causing the death of the cell and consequently the death of an insect. They have unique mode of action because to form the pore, they have to interact with a lipid molecule that is specific for some insects. And this is ceramide phosphoethanolamine. They are toxic for the larvae of Colorado potato beetle and western corn rootworm. We think that our bioinsecticides could have some success because they seem to be specific. They were specifically active against these two pests and not toward other pests and some other non-target organisms tested. They are proteins, so they are safe, biodegradable in the environment. And we also think they could be sustainable. Most of the biopesticides used today, for example, Bacillus thuringiensis toxins, they interact by binding to the membrane protein molecules. Proteins are molecules prone to mutations, so the onset of resistance is quite, the resistance develops. Lipid molecules that are receptors for our proteins are stable, integral, and evolutionary conserved molecules. And we think if the resistance develops in this way, it should be delayed, at least delayed. As already told, our invention is protected by international patent application in several states all over the world. And the value of the invention was estimated up to $8 million American dollars. Thank you very much.
Okay, thank you very much, Professor Sepčič. Thank you for your really interesting presentation. As we can see, we can use all these natural, let's say, mechanisms to protect our agricultural production or plant production in order to be also environmentally friendly. But, you know, I was wondering in between your presentation, so could it be possibly that this kind of technology can be used basically to combat to other pests in agriculture production? For example, in this year, or for now for 3 years in a row, Haliomorpha halis, you know, the brown marmorated sting bug, is causing quite a lot of damage, especially in the fruit production, and also in now vegetable production as well. So what do you think?
Yes, perhaps we have to test it. We tested it against some other dipteran species, for example, Drosophila suzuki, some other coleopterans, and also some other hymenopterans, but not these. We didn't do these experiments. The proteins were tested also against snails, and now we just started testing it on non-target beneficial insects like honeybees, but it was interrupted due to the COVID pandemics. Perhaps it has to be tested. It all depends on the presence of this lipid receptor in the midgut of the insect, target insect.
Yes. Okay, and due to these environmental changes we are facing, so, you know, the temperatures are rising, and I assume that also pests are adapting to these changes, yeah? So this is quite a challenging area for the research as well. So how do you, let's say, see this kind of technology adopting in a few years' time, according to the climate change, of course?
We will see. You know, I'm a simple biochemist and not an agricultural. We have excellent collaboration with Agricultural Institute of Slovenia for considering application and all the other aspects of using this biopesticide. It will be surely not our task to do it. We are basic researchers.
Okay, so now you basically are leading us also to the topic of cooperation, which I think it's essential for the future. So interdisciplinary approach, so combining all the different aspects from different sciences, and then we can find the proper solution for the future. Okay.
I absolutely agree with you.
So thank you very much, Professor Sepčič. Just to let you know, we will have 30 minutes at the end of the all presentations for all others to join in this conversation. But now I would like to introduce you to our second speaker, who is Miss Andreja Žgajnar Gotvajn from the University of Ljubljana, Faculty of Chemistry and Chemical Technology. She will be presenting our 3 fields of research in the framework of removal of emerging contaminants. So first, she will present proven advanced oxidation processes for removal of micropollutants from industrial and municipal wastewaters and waste biological sludge using ozone-based oxidation processes. Then she will also present another approach which deals with reuse of pyrolyzed waste biomass for removal of antibiotics from wastewaters and soil restoration, while in the last part she will be talking about innovative approach for removal of microplastics from wastewaters and surface waters. So please, Ms. Andreja Žgajnar Gotvajn, the microphone is yours.
Thank you very much for the invitation and to opportunity to so everything is okay. So do you see my presentation?
We can see. Just put it in a presenter mode, please.
Yeah. Okay. So perfect.
Okay.
So thank you very much for the invitation and the possibility to present our research work as well as part of cooperation with other partners abroad and of course industry. as it has been already mentioned, I'm going to talk about reduction of emissions of emerging contaminants, because these are actually chemicals which has been recognized lately as potentially risky chemicals in terms of their persistency and non-biodegradability, as well as, of course, they can pose different adverse effects to the ecosystem, environment, and of course humans as well. So first, our research is dedicated to different advanced oxidation processes for removal of emerging contaminants from wastewaters, as well from waste activated sludge. Advanced oxidation processes, which are mainly based on different photocatalytic processes, chemical or photochemical processes, as well as in combination with different physical and photocatalysis, are very efficient, can be very efficient for the removal of such contaminants which don't go biodegradation in conventional wastewater treatment plants with microorganisms. So we focus our research regarding different antibiotics used in human and veterinary medicine on ozone-based advanced oxidation processes. So that means that we combine ozone with peroxide, UV light, and of course different catalysts. And we use those methods on wastewaters as well as on waste biological sludge, which is usually a problem because a lot of antibiotics can absorb on this sludge. So with this approach, we can increase anaerobic treatability of the sludge, so we can reduce its toxic potential and, of course, enhance biogas production to enhance the energy efficiency of such process. And of course, we study different aspects. We study kinetics, we study conditions in different reactors in batch as well as in continuous reactors to try to optimize those processes to get the best treatment efficiency as possible. Next part of our research is also some kind connected with the removal of emerging contaminants, because we focus on the production of the biochar from waste wooden biomass. We have done quite a lot in the field of use of waste, for example, apple tree branches, and then we also focus on a typical wooden biomass found in Slovenia, like oak and spruce and beech. And we pyrolyze it under different conditions, from very small system, actually, which can be used also at home, to more industrial system where we measure the formation and the quantity of the biochar, as well as liquid and gaseous products. And we try to characterize it in terms of active surface area, the size, and the distribution of the pores. We also try to use different methods for the enhancement of the porosity to obtain the material which can be used as biochar, maybe in agriculture, to increase the water holding capacity, or to prevent the erosion or leaching of different nutrients. As well, it can be suitable for treatment processes for the removal of emerging contaminants. And of course, we also try to use it for the removal of different antibiotics, which is actually now in the focus of our study, together with the partners from Portugal, from Lisbon. And the third part of our research, which is very important in terms of two quite big Slovenian projects, we work on microplastics. That means that we try to age the microplastics, so to assess what are the impact of different abiotic factors, and as well as biotic factors, because microplastics particles in the environment are usually inhabited by different bacteria and other organisms, which affect their mobility and also their ability to be a vector to transfer pollution into other compartments. And we focus mainly on the interaction with different types of microplastics with floating plants to develop some kind of phytoremediation technology in pilot scale, where we would be able to retain the microplastics with plants.
I'm sorry.
Yes.
The time has sadly passed, so please summarize.
Yes.
And
this would help to reduce the amount of microplastics in the environment. Thank you very much.
Okay.
Thank you very much, Ms. Andreja Žgajnar Gotvajn, for very interesting three, let's say, pilot cases or studies you are working on. But not to lose any time, I will just, let's say, ask you a quick question for this last technology or last case you presented. So the wetlands of this case can be also implemented on the household level as well?
Yes, that's our final idea. Now we are in the lab scale. We have like a small artificial pond or maybe wetland, and our intention is to finish somewhere outside in the field.
Okay, thank you very much. So there will be opportunity for another questions later on. But now please let me introduce our third speaker, Mr. Matevž Dular, also from the University of Ljubljana, Faculty of Mechanical Engineering. He will be presenting the cavitation. So this is the rapid evaporation of water. Cavitation releases huge local pressures and temperatures that can be used to treat water. And due to these breakthroughs of basic research in the last 10 years, his team were able to obtain a project from the European Research Council, which allows them to study in detail the interactions between cavitation bubbles and various contaminants, for example, viruses and bacteria. In parallel, they have developed several devices in recent years for which they have obtained international patents. As part of the cooperation with several companies, they managed to include the cavitation process in the chain of wastewater and sludge treatment. Last but not least, their work is echoing beyond water treatment in fields of medicine, so targeted drug deliveries, chemistry, acceleration of chemical reactions, ecology, soil cleaning, and engineering, so development of new materials. Please, Mr. Dular, the microphone is yours.
Yes, thank you. Hope you can see my screen. Let me just start the video. So I'm going to talk about bubbles. It's called cavitation. So it's something very similar to boiling, but instead of increasing the temperature, what we are doing, we are decreasing the pressure. And we are doing this by pushing the water through a very, very narrow gap, what you can see here. This is a very high speed video. And the important part is when these bubbles collapse, they create very high pressure, very high local pressures, and very high local temperatures. They can go up to tens of thousands of Kelvin. And what you can see here actually is the shock waves which are produced during this process. Our research is sponsored extensively by the European Space Agency, the National Agency, and lately by the European Research Council. So let's look at the science behind it. So I'm coming from the engineering faculty, so cavitation was many times regarded as a bad phenomenon because it destroyed or damaged water turbines and pumps. And our idea a couple of years ago was maybe we can use this bad part of this process to our advantage and try to kill bacteria or viruses by it. So in the last, this was maybe 7 years ago, it started 7 years ago, we've published a couple of, let's call them breakthrough studies. For example, we've shown what you can see here, inactivation of viruses. We've eradicated different types of bacteria by cavitation. We even removed pharmaceuticals from wastewater. And the final one is we increased the yield of biogas from waste water sludge. And these studies basically enable us to apply for the European Research Council project, where we can really go into the details because the basic mechanisms are still not known, what goes on in there, so we cannot optimize it. And in the last 2 years, we published new studies where we really go into details and we see how a single bacteria and single cavitation bubble interact. Also, we're looking how the clouds of bubbles interact, and we even go to chemistry of bubbles. That's the science behind it. But on the other side, we are not sleeping in terms of engineering. So we, since 2 years now, we filed for 3 patents. One is already accepted in the US, and 2 other ones are now in the process of obtaining in evaluation process. These are EU patents. And we are working on these patents together with a couple of larger companies and a couple of smaller companies, which I cannot disclose at this present time. And the thing is, it goes beyond only water treatment, right? Because first of all, we're treating dirty water by bubbles, and we're producing much cleaner water, which goes out of the wastewater treatment plant, for example. But also, by doing this, we're also treating the solid mass inside this water. For example, we are removing the heavy metals in it, so you can use this for fertilization, and we're gaining more energy out of it, so we can basically close the energy loop of the whole process. And as it was already said, we're also looking at it in situ soil treatment, medicine, chemistry, and engineering. Thank you.
Thank you very much for really nice and executive presentation. Well, yeah, it really shows that it goes well beyond this, let's say, essential cavitation process. But now, let's say that we connect to this very hot topic at the moment, so COVID-19.
Yeah, we are thinking about it. The problem is it's kind of a dangerous to play with it. So what we're doing right now is we're working on surrogate coronaviruses. It's an avian coronavirus, and we're doing this together with the National Institute of Biology to try and treat it.
Okay, so it's
possible. I cannot tell you any results yet, right? So,
no, I know.
But
okay.
Hopefully it works.
Yeah, let's keep our fingers crossed. Okay,
yeah.
Thank you, Mr. Dular. So to carry on to our next speaker, Professor Dr. Domen Leštan from the University of Ljubljana, Biotechnical Faculty. He will be speaking about the new method of cleaning contaminated soils with heavy metals, especially in certain parts in Slovenia, such as Mežiška Dolina, Celje, and Litija. So he will be talking about the solution called ReSoil. It is the only commercially available technology at this point that allows the effective removal of heavy metals from the soil, while on the other hand not damaging the soil, which is of course important and endangered natural resource. At ReSoil, so at this project, this technology, all processes take place in a closed technology loop so that there is no wastewater and the main reagent is recycled. The method is useful for cleaning as well as urban land, for example, gardens, parks, agricultural and industrial land, and as well military training grounds and shooting ranges. So please, Professor Leštan, the microphone is yours.
Okay, thank you. Do you hear me? I will now start with my presentation. Hopefully there will be no problems. Do you see the presentation? No, not yet. Do you see the presentation?
Not yet.
Yeah, again. Now?
Still no.
Do you see it now?
Yes, it's loading. Great, thank you.
Okay. So Envid Limited is a spin-off SME from University of Ljubljana, and the University of Ljubljana developed so-called ReSoil technology for removal of heavy metals and other pollutants from contaminated soil. ReSoil is therefore a soil remediation method. Contamination of soil with so-called heavy metals such as lead, zinc, cadmium, copper, arsenic is widespread and long remained unsolved worldwide problem. The harmful pandemic effects of heavy metals on human health is well documented, and governments are now setting remediation of contaminated soil as national priority. Currently, sites contaminated with toxic metals are mostly being excavated and the soil landfilled as hazardous waste. Soil, however, is a non-renewable substrate with an extremely slow pace of regeneration. World soils are under serious threats from the modern society and increased urbanization, and also from events of erosion caused by climate changes. New remediation technologies are therefore sought as that are both capable of both mitigation of pollution and preserving soil as an indispensable natural resource. You can see in this slide the urban contamination because of the long history of industrialization, and then the case of contaminated soil in Slovenia, in Meža Valley, and the problem with lead that is lead is very problematic in the United States. Our ReSoil technology operates in a closed loop process, recycles the main reagent, which is agent, Celtic agent, and all processed water by using inexpensive and waste material. Where little fresh water is used, no wastewater is generated. Where little solid waste is generated, and this could be used in a circular economy. The remediation process and the remediated soil are free of toxic emissions. ReSoil technology removes heavy metals and preserves soil as productive natural resource. It addresses all three aspects of sustainability: economic, environmental, and social. Minimal infrastructural requirements enables for on-site operations using mobile ReSoil remediation units. The ReSoil economy is an economy of scale. The overall cost is expected to decrease with the quantity of soil taken into remediation. And you can see in this slide the scheme of the process, and inside of our demonstrational plant in Prevalje, and a picture of demonstrational garden also in Prevalje. The ReSoil technology is applicable for reclamation of parks and other public areas with contaminated soil, contaminated agricultural land, brownfields, sports, military shooting grounds, etc. All around the world, urban agriculture is booming, often on contaminated soil, fulfilling diverse economic and social function and reducing food mileage. Remediation and reclamation of urban soils for the production of safe foods is perhaps the most exciting and challenging prospect of using ReSoil. The ReSoil technology is highly innovative, and it is internationally protected by 3 patents. It is regarded as a breakthrough, market-disturbing technology. ReSoil was awarded with the Seal of Excellence from the EU Commission, and this allows projects with ReSoil technology to access EU structural and cohesion funds. Thank you.
Okay, thank you very much, Professor Leštan. Okay, I know that your, let's say, technology was also awarded 10 years ago. So basically your startup company, which you established together with one of your postdoctoral and doctoral students, Ms. Neža Finžgar. So how did you develop, let's say, since then? Are there any improvements? Are there any upscaling?
Yeah, well, the technology changed a little bit from then, and we managed to obtain funds from industry. So we did fund, and with European funds, we got also one Life Plus Spread project, and together with funds from industry, we were able to erect, to build up a demonstration plant in Prevalje, together with the University of Ljubljana, we managed one demonstrational garden with remediated soil. So the technology now is on the brink of commercialization. So we are looking now for another funds from Europe, from SM2 funds, which would enable us to build up a large mobile remediation plant, which will be already commercial. Yeah, it would be commercial capacity plant. And on the other hand, we are still developing this method, not just for heavy metals, but also for other pollutants, for example, arsenic. Now we are preparing a new patent on that. because technology, we improved it quite well. Also for these pollutants, we are calling now SME Plus, ReSoil Plus. And we are also improving the technology for removing organic pollutants. So because some soils contain both types of pollutants, organic and inorganic. So we have, for this now, we are participating in one European project. So the funds for this are obtained from European projects.
Okay, good.
And
Thank
of course,
you very
we're looking
much.
for commercialization. So we present the technology in Shanghai, which was in a national pavilion. And yeah, so we are trying to find the money for big scale application.
Perfect. It's very nice to hear that things are developing. Thank you very much, Professor Leštan. So now our next presenter, Mr. Aleš Mihelič from Gorenje company, one of the biggest Slovenian companies producing kitchen appliances and all other, let's say, useful things. Of course, the company is as well as one of the most ecologically aware companies in Slovenia. They already in 2004, as first in Slovenia, published the EMAS, which stands for Eco Management and Audit Scheme, environmental statement. Since then, every year the environmental management system at Gorenje results in reduction of environmental impact. In this presentation given by Mr. Aleš Mihelič, two features that will help reduce pollution of water are presented. So please, Mr. Mihelič, the microphone is yours.
Thank you. Let me share the screen. So as you told, we are one of the, let's say, major European producers of the washing machine and home appliances. And the reason why I'm actually participating in this discussion, water and soil, let's say, mitigation in principle, we see that if you look our appliances on global scale, about 75 million cubic meters of water annually flows through our appliances. And now with the, let's say, discovery of the microplastic as a result of the, let's say, wear of the textile, also this microplastic flows through our washing machine. And if you look in this graph, you see that actually, according to the science data, about 30-35% of the microplastic is actually generated through the textile wash in the washing machine. The second largest actually is the tires from the cars. So I will not go into details that actually the microplastic put a lot of, let's say, negative influence in the health of the human, but also in the soil, because in a lot of countries, actually the waste water is used for the agriculture watering, and actually this land is then the end filled with microplastic and to become at the later stages even infertile. So a case of such a problem is most prominent actually in Israel. So as an ecologically aware company, we want to actually contribute to this topic. Majority of the solution now, or let's say the development, is going into the filtering of the microplastic, but we all know that if you want to filter something very small, then the filter normally clogs very fast. So this is the reason why we are looking together with Institute of Josef Stefan and biotechnical faculty for another solution. This is actually photodegradation, where all organic pollutants, including the microplastic, will be dissolved in the CO2 and water, so that actually we could have the clean water And not only that we will remove the microplastic from the wastewater. The idea which we're following is that we will reduce the amount of the water used in the washing machines at least for 10 times. And all this could be also very efficient in the terms of the degradation and of the microorganism in the end. So as I told, the idea of this project is that we have at the end zero waste water flowing out of the washing machine there. The another project is also related to the water, and this one is actually even more known by the normal people. So this is everyone who washed sometimes clothes also see that instead of getting white clothes, the clothes are pink or very gray. So this is due to actually the unbound dye actually dissolved in the water and then deposited to a laundry. And you all know this commercial color catcher sheets. What we have actually discovered in our analysis with the partners is that actually these color sheets work, but the problem is that they work too slow, because actually the effect of these color sheets is only about around, let's say, after 30 minutes. And what is the problem is that actually the clothes colored even much faster, let's say in 2 minutes. And we are developing here with the faculty for the textile in Maribor, actually our nanocellulose dye absorber, which is very fast and very efficient. And you see here in this picture that actually the amount of the let's say dye taken very fast is increased. So this is why we are now together with all the partners and also the Institute for Cellulose and Paper. We are actually going to the test pilot production of this nano.
Mr. Mihelič, please.
I'm just finishing. So
okay,
this is actually my last words.
Okay. Thank you.
Okay, thank you very much. Yes, okay, so I can imagine that in a few years' time, these technologies, so you presented 2 of them, they will be incorporated in our washing machines, right?
Yes, this is the idea.
Okay. Okay, good. So you will then collaborate with, let's say, some other companies regarding that. So you will patent this as well, yeah?
Yeah, so this is idea. We normally, as a large company, we are aware that the knowledge is actually, let's say, developing so fast that even we have 300, let's say, researchers and developers in the company, that we cannot follow the development in all areas. So this is why we collaborate with the outside institution, especially, let's say, we prefer cooperation with the Slovenian ones, but if we don't get the competitive knowledge, then we use the knowledge where we get it, so in global market.
Okay, that's the main aim. Okay, thank you. While I was listening to your presentation, I was imagining, because now all our clothes are mainly made of synthetic materials. So I was imagining myself, oh no, we are almost eating each other's laundry.
Yes, that's true.
Okay, good. Thank you. So our next speaker, Professor Dr. Miran Lakota from the University of Maribor, Faculty of Agriculture and Life Sciences, will present us their research work on how they started 20 years ago with first precision agriculture applications. I'm really looking forward to this presentation because myself, I'm also sort of a digital enthusiast in agriculture. I think this is one of the ways that we can save our planet. And he will be presenting how they come to first autonomous field robot and how they implement it together with their partners and how they implemented the use of drones in Slovenian agriculture. And after that, he will present Interreg CEA project, Transfarm 4.0. And this project addresses the issue of technology transfer towards farming business in Central European regions, characterized by different degrees of technology intensity in their agricultural practices. So please, Professor Lakota, the microphone is yours.
Thank you very much, and hello to everybody who is today with us. I hope you can see my presentation, and I'm coming from University in Maribor, from Faculty of Agriculture and Life Sciences, and I'm the head of the Department for Biosystem Engineering, and today I will present what we have done already for the sustainable future soil and water health. I will speak about automatization and robotization in agriculture, and this field is, in my opinion, very important because this precision and smart farming agriculture is a combination of economics and sustainable food production. So my name is Miran Lakota, and my name is not so important. More important is this company that you can see after my name. Because this is a work of the whole department. It is a work of my colleagues, students, and external co-workers, because in our opinion is that especially in these 4.0 times, it's very important to have a cooperation with other researchers and people that are working in this field. And also this 4.0 revolution is he targets all fields of our life. So what we are doing, we began with the precision agriculture actually 20 years ago in 2001. It was first diploma in the field of precision agriculture. It was only the following of the kinematics of tractor in the field, but then later we have development these researches through the image analysis. We have made that researches about how we can predict yield on apple trees with digital images, and these skills are then development. And here we also started in 2008 with the first small agriculture autonomous robot farm beast on the contest field robot event. Here on the left you can see our award from the last year when we arrived the first place in freestyle discipline. The first prize was the award for the presenting of different kind of destroying weed, and one of them was also with the laser that is totally free of pesticides and environmental friendly way to destroy weeds in the field. But what is most important, like these students robots and activities, this picture in the middle where you see a lot of people, it is a pivot point of our department. It is that was made it in year 2015, It is a field robot event on our faculty in Slovenia. And from this point, on this event, we become a visit from the people from Italy, and then we started with, let me say, the development of the real field robot. Work first on the basis of the contracts, and then later also with the project. Here on this picture that is showed left down is a autonomous field robot Rovitis 4.0 that was shown last year on the Agra fair in Gornja Radgona. And we can say through all this research work, we are today one of the leading group for agriculture robotics in a wider region with many national and international awards. And what is the main point of our work is to develop a new hardware and software, and also implementing with evaluation of new sensors systems for agri-robotics. Now at this point on our department are many projects are going on. You can see here on the left that's our students project, European Innovative Partners project, also in Italy and in Slovenia. There are Interreg project. I will later speak about this Transfarm. And yes, we have also a lot of cooperation with the industry. And here in the middle, you see the...
Can you please sum up?
Yeah, I will short finish. Well, we have adopted in last year the using of drones in Slovenia together with company Thermodrone. So the using of drones in Slovenia is not more future, it is a reality. In this year, many applications and also have made it, and also by the big farmers already. And we have also cooperation with Firma Refarmo with this Earth observation with satellites. And this program, this Central Europe project Transfarm is, we have 5 partners, and it is about the promotion of precision agriculture in Central Europe. And we have also a pilot project, but it is too late, too less time to present all these activities that we are doing in this project, but you find anything on the website. So sorry for delay, and thank you for your attention.
Okay. Thank you very much, Professor Lakota. Okay. Yes, so during your presentation, I was wondering how all these digital solutions can be basically adopted to the Slovenian agriculture, which we know faces a lot of challenges in terms of, let's say, hilly production. I mean, so that we have very diverse terrain, and these digital technologies are related to the satellite, images. So how can this be, let's say, adopted to the smaller farms which are situated in that kind of area?
Yes, in Slovenia, we have a lot of small farms, and we have think it from the beginning how to make this technology interesting also for the small farmers. First of all, we have think it that this is how should I say, you must see on this digitalization and of involving these technologies as a process. Years ago, we have adopted tractors in the agriculture, but not all farmers have tractors on the first day. Today, all they have a two or three pieces of tractors, and we see on this like a process that will during a couple of years, the equipment is cheaper from year to year. We have a more and more solution, and but also on the other side, we see that the technology is not enough. This 4.0 revolution is really going to all parts of our life. And we have made it an autonomous robot. Okay, we was happy. It is going, it is working. But then somebody has taken questions. Oh, by me, he must cross the road. Can I do this?
Okay, so it's basically a long-term process, and it takes, let's say, some time to adopt this kind of new technology, especially in the agricultural sector.
Yeah, and we become from day to day new challenges with a simple question: how should I cross the road?
Yes. Very simple but challenging questions. Okay.
It can be problematic, so simple.
Yeah.
Yes,
Okay.
yes.
Thank you very much, Professor Lakota. So not to lose any more time, I will introduce you to our pre-last speaker, Dr. Professor Martina Bavec, also from the University of Maribor, the same faculty as Professor Lakota. So she will be presenting the organic agriculture as a model for circular economy and the tool for achieving sustainability goals of United Nations. So her presentation will focus more on this organic agriculture model. Of course, we know that organic agriculture provides several environmental, social, and economic services and is recognized as a part of solutions for achieving those sustainability goals. Based on several research and development projects from this faculty, basically the presentation will present supporting this development also in Slovenia, so the development of organic agriculture in Slovenia, including direct collaboration with several farms, trainings, demonstrations, and companies, evaluation materials for use in organic farming and processing testing, and also innovations in machinery development, production techniques in agriculture. And research results which will be presented, they will also focus on differences in food quality of organic versus conventional food, and effect of organic food on human health and environment. And this basically is supporting us for sensitive group of population, including also the HoReCa sector, so hotel, restaurants, and cafes, which basically was quite infected also due to the COVID-19. So please, Professor Bavec, the microphone is yours.
Thank you a lot for the introduction and to giving me this opportunity. But as I have had some worries with the communication with you, if I will be able to open my document, it happens that I cannot do it. But if you can help me something, it would be great. But I could do it also without looking to the.
So if I may help you, sorry. At the bottom, you can see green button. It's written share screen. Okay.
Yes.
In a Zoom, yeah, you just select it and then select your PowerPoint presentation which you'd like to share.
Yeah, but it's a problem that I cannot see it. I can see only Dropbox, OneDrive, Google Drive box, but
you need to have presentation open. So
yeah, it is open. It is open, but it doesn't work.
Ene, could you
Yes.
share your screen with the presentation?
Sorry, I don't have Martina's
okay, then I have, so I can share. I can share the
if
screen.
you have her presentation, yeah.
I have
please do
PDF version, yes, so I can share my screen. Let's see, share.
And then Martina can just say next slide, or I don't know.
Yeah,
and
yeah. Let me see, how will this work then? Okay.
I'm going to stop sharing on purpose because we were looking at all your computer.
Yeah. Okay. Thank you for that. G drive. Okay, maybe Martina can just start talking, and in between I will upload a presentation.
Yes.
Yeah.
I would like to present organic agriculture as a model for circular economy and a tool for achieving sustainability goals of United Nations organization. Namely, we are all aware about all these 3 pillars of sustainability, but also in agriculture, if we are not evaluating them through real and good indicators, it could become only greenwashing of agriculture sector. And agriculture sector is nowadays tipped among many directions. We want to produce food, we want to have energy from fields, and we would like to produce several materials. But on the other hand, we are facing with water and soil pollution, and also with degradation in biodiversity. So if we are coming back to organic agriculture, it is in fact closed cycle, and we are working in the cycles with nutrients and trying to give as less as possible of all inputs which are coming from the industry, and we want to make the circles on the farm scale or on the regional scale. It's the other possibilities. But in fact, to transport many materials like feed for the animals from South America or something like that, it is not very much appreciated. Thinking about all these problems, we find out several years ago.
Professor Bavec, can you just tell me, I am sharing my screen, and just tell me when to shift, okay?
To the slide 7, please.
Okay, sorry, one more thing, Tina, maybe just try to press Ctrl and L together. That is going to present remote.
It's in PDF, you know, that's why.
Yeah, it's in the PDF.
Yeah.
It's,
but even PDF can go Ctrl L.
Ah, okay.
Control. Can you? Well, I can.
Is it working or no? Or
No,
maybe just.
It's not working. Can you? No, it's not working.
No, Vesna, may I ask you to go to the slide 7 and it is okay?
Okay, yeah.
It is here. We have been faced years ago that these basic principles of organic farming can support the problems concerning the pollution of water, concerning pesticides, and on the other side also the nitrogen. Please, next one. Organic agriculture supports also soil health because we are putting organic carbon from the natural sources like manure, compost, green manure, or cover crops. And all these amendments are improving soil. And also in the change of tillage, we can change some health status of our agricultural soil. And in this direction, we have collaborated in several projects, and one of it succeeded also with a new machinery development in one Slovenian company. It is called roller crimper. Next slide, please. Based on this here mentioned 2 projects, SoilVec and InterVec, we have introduced many new solutions into the crop rotation in organic production, also on our Slovenian fields, especially in field crops and vegetable production. Next one. But on the end, our final product is organic food, and as I mentioned, we have to monitor or evaluate all these effects. And years ago, we started to use life cycle analysis and calculating ecological footprints. And we have done also in one national project dealing with organic food in gastronomy, where we found out that the menu composed by organically produced food can reduce up to 30% of ecological footprint compared to conventionally produced ingredients. Next one. But organically produced food could have positive effects also on the health of the population. We find out in one basic research project some years ago on our faculty, where two groups of students have been eating different diets, organic versus conventional, and we find out that the content of organophosphorus compounds from the pesticides in the group eating organic was significantly lower compared to the group eating conventional. Next one, please. And of course, we published in several conferences also these our results. Next one. Nowadays, we can see that also European Union in Green Deal has some strategic goals also on the topic of organic farming, namely at least 25% of all agricultural area in Europe should be converted to organic. In Slovenia, we are now on the level of 10%. But on the other side, I have to stress that this fact, converting conventional farming towards organic, has also big potential effects also on some other strategic goals of Green Deal, like less pesticide use, higher biodiversity, less mineral fertilizer use, less antibiotics in animal husbandry. And also today's presentation of some colleagues are in fact supporting all these orientations which became goal or target of the whole European Union community. Next one. So I can conclude that organic agriculture is the solution of for achieving quite some goals of United Nations organization towards 2030. You can see some of them. Next one. Yeah, and I would like to finish with the slide of my good colleague, Professor Dr. Narodoslavski from Technical University Graz, who showed us in one event on our faculty that it is not a rocket science to see that conventional farming is a part of the problems that we are facing in agriculture, and organic farming is a part of the solution. And that, yeah, would be my end of speech.
Okay, thank you very much, Professor Bavec. All right, yes, basically it's not a rocket science, as you concluded, and everything is interconnected and interdependent, yeah? So if we would like to stay healthy, we have to eat healthy food, which is produced in healthy soils and irrigated with healthy water, clean, healthy water. Okay, but now just let's say one quick questions about this, let's say the offer, so the market for these products is basically very wide, and the consumers are now basically willing to buy those products, but we know that there are around 20% more expensive, let's say, from the other products. So how do you see this in the future? So do you think that this will change in a way that majority of us will be able to afford this?
Yes, the market is much bigger than nowadays supply, and that's a big potential also for Slovenian agriculture on one side. But the price depends on product. We have on the market also in Slovenia a lot of organic dairy products which are the same price as some conventional. And also with the change in taxes, introducing green taxation, we could make this kind of products cheaper. And also this is one of the statements also in the Green Deal that we should change in the future taxing patterns.
Yeah, for sure. Okay, so thank you very much. And I now, before our last but not least presentation, I'm encouraging you all to write, let's say, questions in the chat area, if you have some, so that then in the discussion part we will go quicker through, that we won't forget anyone who would like to say something. But okay, our last but not least, as I mentioned, speaker, Miss Mateja Geder from the University of Maribor, so Techno Center, Technology Transfer Office. She will present us innovation paths, so 8 areas of opportunities for companies, SMEs, to innovate in the 4 key sectors, and these are energy, logistics, safety, eco-friendly technologies. She will be presenting us the Interreg Adrian Shipment Project, which is strengthening the intellectual property and technology transfer processes in green sea mobility sectors, focusing on the maritime and shipbuilding industry. In that, I'm leaving the microphone to you, so please.
Thank you so much for this introduction. I hope you can hear me well. And that you can see also my presentation?
Yes.
Okay, so as yeah, first of all, good morning to everyone. I'm happy to be here, and as announced correctly, I will be presenting technology and innovation paths as defined in the shipment project. The main aim of the shipment project was to set up an innovation system that would focus on maritime and shipbuilding industry across the Adrian area, and we have identified these 8 innovation paths based on the predefined trends and megatrends, which you can see on the left-hand side, and of course based on the four sectors that are considered to play a key role in the shipbuilding and maritime industry. As far the energy sector is concerned, the innovation potential lies in increased production of electricity from renewable sources, where shoreside solar power for ships and offshore wind energy supply to ports will play an important role, or already playing an important part. Then another highlight would be innovative power storage system and advanced materials and design of solar panels, as well as wind turbines and wind towers. Focus points for the future development in the logistics sector are definitely coordination and optimization of waterborne traffic with train and road transportation, along with advanced platforms and real-time data traffic, intelligent communication and monitoring system, as well sustainable signaling system. Of course, new transport routes with corridors will have to be developed to enable smooth transportation. Main challenges in the safety sector relate to protection of coastal areas from natural calamities, freshwater scarcity, and recycling of desalination waste is another key issue here. And the entire ICT development to autonomous ship and connection to smart port is another highlight in this area. Recycling fiberglass is the main emerging technology in the shipbuilding industry. Some Slovenian companies are already active in the field of electromobility and hydrofoil technology. Combating microplastic has been mentioned today, so it's of course very much topical also for our project. Here you can see a list of keywords that are actually from project ideas developed by SMEs. In our project, we have gathered about 100 project ideas of SMEs that are now seeking partnership with other industry partners or researchers. And of course, you are welcome to explore these ideas. We set up a special website for this, which will be also maintained after the completion of the project, support2finance.eu, when you can, of course, explore this idea and contact us if necessary. So this will be all from my side for now. Thank you so much.
Okay, thank you very much, Ms. Geder, for your informative and exclusive presentation. All right, so these Interreg projects, as far as I know and I'm familiar with, they are very applicative. And they are really trying to find a solution which can be directly implemented into the practice for various, let's say, types and ideas. And yours as well, as you presented, you included also SMEs in this. And now, so 100 ideas are being out there now trying to find the right partners and right financing to bloom in practice.
Yes, correct. Our job is to promote these project ideas and to help companies to find adequate collaboration partnership for taking these ideas further.
Okay, so now I think that Tina is guiding our time, so she's precisely measuring it. So how much time do we have until the end?
We are a little bit past. We can still, if there is some kind of discussion that want to really reveal, we can have some time. Otherwise, we can close the session.
Okay, but I would anyhow encourage any of you to, let's say, open the debate on any issue that was presented. Did someone would like to add anything, some thoughts? Are there any connections between the projects? Did you see it? Or maybe to Okay, there is one question from Miss Anna Fekonia for Professor Leštan. So who is your target customer for ENVIT company? And how are you going to start with the commercialization of your idea?
Well, the targets, it depends on a continent. So, for example, in European Union, we will probably talk with governments and also with municipalities and cities. Also some major industries which are or are responsible for contamination. In China, we are in contact with some major remediation companies and trying to sell actually our technology there. And we still didn't have much activity in the United States, but I think that the United States is probably the biggest market for us. So how are we going to start with our commercialization? We have built, or we are in the process of building a mobile demonstrational unit. We'll probably build two. One will be built in a project, in the European project, which is already ongoing. And then we will demonstrate our technology in situ, because soils are very different in properties and also contamination is very different in different areas. So it's important for us to demonstrate the technology in situ. Yeah. And regarding development, we are counting now on a European money to build, as I said, a mobile commercial remediation plan.
Okay, so mobile, like a truck, so that they can, so that you will be able to move from one side to other side with no problems.
Yeah, that's right. One good aspect of our technology is that it's quite. It does not need a lot of infrastructure. So basically, we're recycling all the processed water, so we don't have any wastewater produced, and all the waste that we have is a solid waste, which is easy to take away. So, and also electricity consumption, it's not so much, and there is no other emissions, which is good. So it is possible to build mobile plants and use it, for example, even in the center of cities. For example, in Paris, where you have this tragic accident when Notre Dame Church was burned and was 400 tons of flat, but emission was emitted to the surrounding. So we can then tackle this contamination part.
Okay. Now, thank you very much. There is another question for Professor Sepčič. What is the basics for the good specificity of the Pleurotus toxic proteins? Can you explain a little bit more?
Yes, thank you for the question. Well, as I told before, the receptor for these pore-forming proteins are lipid molecules. Is a specific lipid molecule that is not present in higher organisms, in vertebrates, in mammals. It is specific to some insects, not to all the ones, and also to some other invertebrates. This is a sphingolipid, and these two insects, western corn rootworm and Colorado potato beetle, we made some lipidomic analysis, and we have proved the existence of this lipid in physiologically relevant concentration in the membranes of the midgut of these insects. We will also try other insects. We are just sending now other lipid extracts from other target insects and also non-target species, invertebrate species, to the lipidomic analysis. We presume that also some other insects have this lipid. In fact, there are some proofs that it exists in other insects, but why these two coleopteran species are susceptible, no? So western corn rootworm and Colorado potato beetle, they belong to the same family, Chrysomelidae, no? And the pH of their midgut is acidic. And we know from the experiments with artificial lipid systems that the binding of our proteins from mushroom proteins is the best when they are in acidic milieu. They do not bind if the solution is alkalic. So these coleopteran species, they have acid pH in their midgut. For example, Lepidopterans and some other that were also tested, they have alkalic solution in the midgut. So this could be also one of the reasons, or the presence of some specific proteolytic enzymes in the midgut. And we have to find it out still.
Okay, so you are still developing your research, but there is another question for you, and that is when can we expect the bioseed from Pleurotus mushrooms on the market? But as far as I understood from your presentation, you are still in the developing phase.
Yes,
but let's say approximately.
I don't know. I'm a basic scientist. I do not know anything about business. So thank you for the question, but I'm not the right person to answer it. As I told already, the Knowledge Transfer Office of the University of Ljubljana and of the Agricultural Institute of Slovenia, we signed this agreement of non-disclosing information. No? So we sent these proteins to the company that was interested. We already got results this spring. They were very encouraging. However, another testing should be done to confirm the results, but it was interrupted due to the
COVID,
obvious reasons. And we will see what we develop. Okay.
Okay, but there is a promising future for this biopesticide for sure. Okay, thank you very much, Professor Sepčič. And then is another question for Professor Martina Bavec. How are yields of the organic farming compared to the conventional farming? Should we also focus on what kind of food we produce, for example, vegetables versus meat, beside how the food is produced for more sustainable agriculture?
Yes, we should focus also on the kind of food that we produce, especially if we know that worldwide around 70% of all cereals that has been produced are going then to the animal feed, and only 30% of all grains produced are consumed directly. So if we would shift this percentage, we would immediately have much more food for feed the world, and there will be no problem about the rising population and all these questions which are nowadays going on and were also today presented in the introduction. And concerning the yields, yields are on general a little bit lower, but it depends on crop, and it depends also on the region. There are studies, meta-analysis, and I can conclude also with our own long field-term field experiments that we are conducted it on the field of Faculty of Agriculture in Maribor, where we find out that after several years of after change or conversion, the yields are going up and are stabilized. It is only a question of the production techniques. We have to assure enough nutrients from the natural resources and use perhaps biopesticides, which are allowed also in organic. And if you would make more research in these gaps, we are not, it is not, no need to be worried about the yields. And also the maximum yields are never optimum yields, neither from the economically point of view concerning the inputs, also in conventional agriculture, and even more it is a problem than in environmental aspects.
Okay, yes. Thank you very much. So are there any other questions or ideas from the audience? I can see it's quite a good big group here. Okay. So I would ask now all the presenters to turn on their cameras again, as well as Tina and Enei, so that we can make one print screen for the memory of this event. So now we are all in? Okay, good. 1, 2, 3, and you smile. Great. Okay.
I'm just going to capture one screen, yeah.
Okay.
Okay, thank you.
Perfect. Thank you, Enei.
Thank you.
Maybe Tina, if you have, let's say, something to add, or maybe some thoughts that are running through your head. We've heard quite a lot of interesting presentations and inspiring as well. So I'm really, really proud to be a part of this Slovenian innovative community and to see that many, many good ideas are there, developing, also entering the market, and they have a big potential for the future in terms of a sustainable future, protecting our soils and water, two of our very important natural resources.
Thank you, Vesna. Thank to everyone. Thank to all the attendees for the great insights. Unfortunately, time goes fast and we have to finish. We will keep the debate alive in mobile and web app, which also enables you to meet the speakers, other attendees and organizers, talk to them, create discussion topics, meetups, share articles and more. There are already links in the Zoom chat box, which will guide you on how to download and use the mobile app. We would also like to draw your attention to our last event, Future Society, on the 24th of November, where we are expecting more speakers, which will be cover specific challenges of collaboration in the field of society. More on the link in the Zoom chat below. We hope you enjoyed this session. Your opinion matters to us, so please give us your feedback. Go to Whova app in the agenda, find the rate this session or click on the link in the Zoom chat box. Find more info about UNI.MINDS on our website. You can find the link in the chat box. So my name is Tina. I wish you all the success and thank you for joining us at this session. Thank you.